Problem number 1. The resistance of a cylindrical brass conductor 0.5 centimeter diameter and 3 meter long is 0.108 ohms. Determine resistance of a cylindrical conductor of the same material at the same temperature having a diameter of 0.25 centimeter and a length of 8 meters. Okay, in solving this type of problem, our first step is to compare the given. Based on the statement of the problem, we have two different conductor. A conductor with 3 meters long and a conductor with 8 meters long. So, to start with, we need to summarize our given so we can determine our unknown. Okay, so let's get the data for the first conductor. So, okay, for conductor number 1, we have a diameter of 0.5 centimeter, a length of 3 meters, and a resistance of 0.108 ohms. For our second conductor, we have 0.25 centimeter for diameter and a length of 8 meters, and the resistance is not given, so therefore it's the unknown. Okay, we need also to observe this one. Determine the reciprocal cylindrical conductor of the same material. The statement signify that both conductor 1 and conductor 2 have the same material. What do you mean by the same material? It means that if they have the same material, the resistivity of conductor 1 is equal to resistivity of conductor 2. Okay, so they have the same resistivity. Okay, if we recall the formula for our resistance is equal to resistivity times length all over the cross-sectional area. So since our resistivity is constant, we can transpose our formula with respect to our resistivity. So therefore, if we transpose the formula, so finally our resistivity is equal to resistance times cross-sectional area over the length. So this formula of resistivity will be substituted to our condition, which is given in our statement of the problem. Doing so we substitute the value of our resistivity, comparing the both data of conductors. Okay, so for resistivity number 1, that is equal to R1, cross-sectional area of conductor 1 and the length of conductor 1 is equal to resistivity of 2, so that is resistance of conductor 2 times the cross-sectional area of conductor 2 all over the length of conductor 2. So we have our final formula for our problem. But wait, we need to review if all data are available. So resistance given, the cross-sectional area of both sides, they are given in diameter. So, and our R2 is the unknown, both length and both sides are given. So we need to deal first with the cross-sectional area of our conductor. Since the conductor is in cylindrical shape, if you recall the formula for your cylinder, that is equal to pi r squared. The cross-sectional area of our cylinder is pi r squared. Since our given is in diameter, we can say that the area, the cross-sectional area, is equal to pi d over 2 squared. So if we use the power, so that is pi d squared over 4, or we can rewrite the value of our formula for cross-sectional area, that is 1/4 pi d squared. So this is our formula for cross-sectional area for the cylinder that will be substituted to our original, to our equation. Okay, so let's start substituting our equation. So R1, what is the value for R1? That is 0.0108 ohms times the cross-sectional area, that is 1/4 pi. The diameter is 0.5 centimeter. Always include the units. 5 centimeter squared. So all over the length, which is 3 meters. On the other side, we have our unknown, R2, and our cross-sectional area, 1/4 pi, the diameter, which is 0.25 centimeter squared, and all over the length, which is 8 meters. Okay, so let's cancel out common units on both sides. So meters present on both sides. Here, our centimeter will become square centimeter. So it will be cancelled out both sides. So the remaining is the 0.5 squared and the 0.25 squared. Okay, so the remaining units is in ohms. Okay, so if we do the math using the power of your calculator, shift solve, your final answer, your R2 is equal to 0.1152 ohms. So this is your final answer for our problem number 1, 0.1152 ohms.